Hey guys, welcome back to another GCSE Maths video. This time we're continuing with doing the past papers from 2024, June paper 2. However, I wanted to try something a little different, which will allow me to put out more videos, but also it might be more useful to you guys. So I'm thinking with this, and again, let me know in the comments if you think this is a good idea or not, that we're going to focus on the hardest questions from each paper. That way you don't have to watch, the question ones where it's like factorize 2x plus 2 or something like that. Instead, we can just focus on the hard questions. That way it's more efficient for you, more efficient for me, and who knows, maybe it'd be more useful. So what I'm thinking is we're going to focus on the last 5 questions from the paper, because these are kind of the grade 7, 8 and 9 questions. However, I do think that I can explain them in a way that even if you're not aiming for a 7, 8 or 9, you can still get marks in those last few questions to help boost your grade up a little bit more. Rather than getting 0, you might get a couple, or even the whole thing. Who knows? Because I genuinely think that if you are currently on a 6 or a 7 in maths, bearing in mind it is April 12th when I'm recording this, I genuinely think you can get basically any grade depending on what you want and what effort you want to put in. So that's what we're going to do for today. So we're going to do the last 5 questions, question 18 up to 22. And yeah, we'll see how that works. But before we get into it, if you've ever found any of my videos useful, if you find this video useful, then please do consider subscribing. It really does help me out. But let's get straight into question 18. I should point out that this was paper 2, so this is a calculator paper, so I will be using a calculator, shockingly. But for this question, there are only 4 red, 3 yellow and 1 green counter in a bag. Tony takes 3 counters from the bag. Write down the probability that there are now more yellow than red counters in the bag. So I'm going to write this out. So we have 4 reds, so let's do 1, 2, 3, 4. We have 3 yellows. That's a horrible idea what I was about to do then. I guess orange is the closest thing I have. Yellow, yellow, yellow. And then we have a singular green. And he's going to take out 3 counters. And we want there to be more yellow than red. So the only way for this to happen is I have to take out at minimum 2 reds. Why? Because if I take out 2 reds, so if I get rid of these 2 for example, then I have more yellow than red, because again, keep in mind, more yellow than red. So essentially they're asking us for the probability that we take out more than or equal to 2 reds. So let's write down the possibilities for taking out at least 2 reds. So you can have, for example, red, red, green. You could have red, green, red, green, red, red, or we can take out 3 reds. Now, the key thing here is we can't take out any yellow, because if we take out a yellow, then all of a sudden we can't have fewer reds than yellows. Now, there is good news here, and you're going to see this in a second, but these probabilities are actually all the same. So it's just going to be 3 times one of them. But let's pretend we don't know that for now, just so I can prove it to you. So, probability of getting a red, red, then a green. What's the probability of me getting a red? Well, there's 4 reds, so it's going to be 4 out of a total of 4, 5, 6, 7, 8 counters. Then if I take away one of the reds, what's the probability of me getting another red? Well, now there are 3 reds out of a total of 7 counters, right? 1, 2, 3, 4, 5, 6, 7. Okay, now I've taken out another red. That's the probability of me getting a green. Well, there's 1 green, and there are 6 counters overall. So now rubbing those 2 out. Please. There we are. Cool. Now, red, green, red. Well, okay, the probability of me getting a red is 4 out of 8 again. Times, well, now I've gotten rid of one of the reds. We need a green, so we have 1 green out of a total of 7. Then we're taking another red, so that's 3 out of a total of 7. So when I said that these numbers are all the same, or these probabilities are all the same, if we have a look, when you times fractions together, you times all the numerators together, then all the denominators. So the numerators are 4 times 3 times 1. Then it's 4 times 1 times 3. Well, they should be the same number, right? Because it doesn't matter which order you multiply numbers in. So 4 times 3 times 1 is 12. 4 times 1 times 3 is also 12. And you're going to notice it'd be the same probability for the last one. So, we're still going to do it anyway because I want to. So 1 out of 8 for the green. Then there's 4 out of 7 reds. Then 3 out of 6 reds as well. So again, I'm only going to bother working out one of these probabilities because all of them will be the exact same, and you can check that if you want. So 4 over 8 times 3 over 7 times 1 over 6. 1 over 28. And again, you can check it right now if you want to, but all of these will be the same. Now the last one we need to do is 3 reds. The denominator is also going to be 28, by the way, for the 3 reds, but let me prove it to you. Well, what's the probability of getting 1 red? Well, we have 4 reds out of 8. Now there's only 3 reds left out of a total of 7 because we've gotten rid of 1. Then it'd be 2 out of 6. So here we have 8 times 7 times 6 again, so it's out of 28. And actually it won't necessarily be out of 28 because we'll times it. So let's just do it properly. Well, now all I need to do is change the numerators. So 4 out of 8, 3 out of 7, and then 2 out of 6 instead. 1 out of 14. So, or 2 out of 28 if you want to write it as 2 out of 28. Up to you. So now the total probability is you just add all of them up. So 1 plus 1 plus 1 plus 2 is 5 out of 28. Again, you can use a calculator because it is a calculator exam. That's a 5-mark question. It didn't take me 5 minutes to do. Well, actually, I just looked at the timer. It took me just about 5 minutes. But you can imagine in an exam, you can actually do this a lot faster. So hopefully that makes sense for question 18. Question 19 is vectors. Vectors is probably the worst answered topic every year. I will link in the description, if I remember, my video on all of the vector stuff. So I have done a grade 9 vectors video where I've go through every single possible type of question, every single past paper question, to help you understand how to do it. But I will give a brief overview here. But if you want more support, definitely go to that video. But the first thing I would do is I would start labeling up everything they give me. So m is the midpoint of OA, which means either side of this is a half, right? O to m is half of the whole line and m to a is half the whole line. They also tell me that n is the point such that b to n is 4 to 5, b to n, n to c. So that'd be 4/9 and 5/9. Cool. Then they say O to A is A, so I'm going to draw that vector on. In fact, I'll draw it in a different colour. A. O to B is B, and A to C is KB. We don't know what KB is. And it asks me to express M to N in the terms of K, A, and B. Give your answer in the simplest form. So, how do we do this? Well, the way I do this is I make it as simple as humanly possible, okay? We're going to write out the steps that you would take to go from M to N. And the key thing is we want to go along vectors that we know. So here's what we would do. I would go from M to A, right? That's my first step of the journey. Then I would go from A to C. Then I would go from C to N. So if you notice how I've done this in like very set steps, right? It's like I'm giving you a list of instructions. Go from M to A, then A to C, then C to N. Now we just need to write down some details on how to actually do this. And again, this bit isn't too bad either. Now M to A, I don't have a vector M to A. But what I do know is that M to A is half of O to A. And do I know what O to A is? Yes, O to A is A. So it means that is just half A. Now I know some of you are probably thinking, why don't you just write half A straight away? For me, in an exam, it's very easy to make mistakes. So I would recommend doing things in as many steps as possible. Okay, take it step by step, nice and slowly. Now A to C, well, there's no way to do it in another step. We know what A to C is, it's KB. So let's write KB. And what about C to N? Well, I don't know what C to N is, but what I do know is that it would be 5/9 C to B. Okay. Now I can start subbing this in. So we have a half A for OA plus KB plus 5/9, and now we need to write how to go from C to B. Well, I can't go just straight down because I don't know any of the vectors. But what I can do is go from C to A, so that'd be minus KB. Why is it minus? It's minus because if you notice, the vector A to C has an arrow. If I'm going in the opposite direction to the arrow, it has to be negative. Then I have minus a, because I'm going in the opposite direction again to get to O, then plus b. Now all I need to do is expand and simplify this, and I'm done, which is nice. So half a plus kb. Then if we expand that, that'd be minus 5 over 9 kb, minus 5 over 9a, plus 5 over 9b. So let's gather the like terms now. So start with the a's. We have half a minus 5 over 9a. And look, this is a calculator exam, right? Why stress? Why not just do it the easy peasy lemon squeezy way, right? Minus an 18th a. I know that looks a bit weird, but who cares? Then let's do the b's. We have plus 5 over 9b. Now we can do the kb's. We have kb minus 5 over 9 kb. So that's 1 minus 5 over 9, which is 4 over 9. So 4 over 9 kb. That's it. Which is 4 marks. Pretty good, right? Is m to n parallel to o to b? Okay, so we've just worked out what m to n is, and we know ob is b. Now what does it mean for two vectors to be parallel? It means that they can be written as multiples of each other. So in other words, I should be able to write m to n as a multiple of b. Now why isn't that the case here? Well, because we have an a. So because we have an a, these two vectors cannot be parallel because one has an a, one doesn't have an a, which means they cannot be multiples of each other. That's it. So no. M to n has an a, OB doesn't, therefore cannot be multiples of each other. There you go, that's perfectly acceptable. So, the curve has equation y equals 2x squared minus 12x plus 7. Find the coordinates of the turning point. If you ever see turning point, then you're going to hopefully immediately think about doing good old-fashioned completing the square, which again is technically a grade 9 topic, but I genuinely think anyone can learn this. Now, the problem here is that there is a number in front of the x squared, which does complicate things. However, one of my students that I was tutoring, they did something different, and honestly, I think it's kind of impressive. Normally, I would factorize out the two, do that, expand it and everything, but he showed me he did it a different way, and I think it was quite genius, which is just dividing both sides by 2. And by the way, I'm not saying this is some revolutionary new tactic, by the way, it's just, I don't know. It's not something I would do personally, but it helped him and a few of my other students, so it might help you guys as well. Now, the key thing here is we have to remember to times by 2 at the end. Okay, so don't forget that. Now we can do completing the square. And completing the square is nice and easy. All you do is you write x, then you half this number, so minus 6 becomes minus 3. Then you subtract that number again, squared, plus the number on the end. That's it. So we have y over 2. Whoops, sorry, that should be squared as well. X minus 3 squared. Minus 3 squared is 9, so that becomes minus. Just so you know, this thing here, this part of the bracket, everything here, is always negative. Plus 7 over 2. And all we're going to do is we're going to combine that using... we can use a calculator, right? Who cares? We can just use a calculator. So that's minus 9 plus 3.5. Whoa, what happened there? Get rid of that. There you are. Minus 11 over 2, or 5.5. I'm going to show you why I'm going to leave it as a fraction, just because I think it's going to make our lives a little bit easier. Because remember what I said, the last thing we need to do is, we need to times back by 2 again, which is a vital step. The reason why this works is factorizing and dividing are very similar things, really. But now we need to work out what the turning point is. Here's the rule. Again, I have a video on completing the square where I explain exactly what to do. So again, you can go back and have a look at that if you need to. But all you need to do is change the sign of what's inside the bracket, so from -3 to +3, and you keep the thing outside the bracket the exact same. So 3 and -11. That's it. Nothing crazy, nothing spectacular. That's it. Not too bad. Nice quick question here. Now, again, transformations is grade 9, but I don't think it's too bad. I think everyone watching can definitely do this. One of those topics that even if you're a grade 5 student, you could definitely do this. So we get the graph y equals g of x, and it's a U shape. Cool, wonderful. On the graph, draw g of minus x plus 2. Now there's two things happening here. We have the minus x and the plus 2. Now if it's inside the bracket, okay, I just messed up. If it's inside the bracket, we do the opposite, and we do it to the x coordinate. So here, it's saying -1 times x, so it's lying to us. We're going to do the opposite. We're going to do x divided by -1. Now some of you might spot that this is the exact same thing. Fine. The thing that's on the outside of the bracket affects y, and it does exactly what it says. So we're going to take the y coordinates and we're going to add 2. So over here, we're taking the x coordinates, dividing by -1. Here we're going to take the y coordinates and add 2. So let's just take a couple of these points. Let's take this point over here. The x coordinate is 1, but now it's going to be -1, because 1 divided by -1 is -1. Again, use a calculator. The y coordinate's -2, but now it's add 2, 0. So that coordinate is now going to be over here. Okay. Then let's choose a different colour. Let's take this point over here. The x coordinate's -1, so now it's going to be +1, because -1 divided by -1 is 1. And then instead of it being a y coordinate of 1, we're going to add 2 to it to make it 3. And lastly, I'm going to take one more point just to be super sure. That's 3, 1. So now it's going to be -3 and 3. If you really wanted to, you could even write it out like this. So we have 3 and 1. After the transformation becomes -3, because we divide by -1, and +3. And then all we do is connect it with a nice U shape. That is actually not too bad. I'm actually relatively happy with that. That's it for 2 marks. Not too shabby. Here we have a circle theorem proof, which honestly, it comes up so infrequently, but this one's actually pretty easy. So proving that AP equals BP, hopefully you know the circle theorem that 2 tangents from the same point are always the same. Now, the question is why? So what would I do in this question if I didn't know the circle theorem proof? Well, the first thing I would do is, as with a lot of these circle theorem questions, you're going to draw the fact that these are 90-degree angles and they're both radii. Now, one thing that I could do to prove that they're the same is I could divide this, because it's a kite, into 2 triangles. And then if I prove that these 2 triangles are congruent, they are the same, then the lengths must be the same because they're identical triangles, right? So here's what we can do. We can say that OA equals OB, because they're both radii. Then we can say that OP is shared. And then we can say that OAP and OBP are right angle triangles. Now, what this means is that both of them are the same because of RHS, right? Because when you have a 2 right angle triangles, if 2 sides are the same, the third side has to also be the same because of Pythagoras. So to work out this side, we would do this side, subtract this side. But of course it's going to be the same if those 2 sides are the same. Therefore, AP must be the same as BP. So honestly, that isn't too bad of a circle theorem proof. But again, it's just proving that these 2 triangles are congruent. And they're congruent because they both have one of the same sides, because they're both radii. Then they share the side O to P, which means the third side has to be the same because of RHS. RHS being a right angle triangle with the same hypotenuse and one of the sides the same. So yeah, that brings us to the end of the video. It was a lot shorter because we focused on the hardest questions that came up in this paper, which again is the last 5 questions. Let me know if you like that format, but I'll leave you to your revision. Have a good day. I'll see you in the next one.